Hello! I've been playing this peaceful, totally non-toxic game for the past couple of years.
Ignorance, man, I'm playing with them.
Let me out! Ah, fuck! Fuck! What is that fucking champion? Fuck! Fuck!
That's get John down.
No! Ryan! Why I want mid lane? Oh, my shit system! They're not gonna give me!
You get the idea. So, how about amplifying that experience, the good one, hopefully, and adding more immersion using lights? Let's get started. We need LED strips or any RGB light source you know how to control. Neatly present the product, take it for a spin, then rip it apart like a cannibal, and then locate the controller. In most cases, the strip you buy is supplied by this controller, which is what we'll modify today for our project. We'll be using these little buddies called MOSFETs, which in brief is a beefier switch that can handle the current of these LEDs and be controlled directly from a microcontroller. Taking a look at the PCB of the controller, we can spot the three tiny MOSFETs we'll be using. First, we need to trace where the gate or the control pin of these MOSFETs are terminating. Using a multimeter, we can easily pinpoint their location. And after some probing around, we know that these three pins are each connected to one of the MOSFETs, one for each channel, R, G, and B, also ground. Soldier time! We'll be soldering some wire to the MOSFET gates in order to control them via an external controller. I'll be marking the ground wire for ease. Logically, next step is getting everything back together. But you thought so, huh? In theory, this should work fine. But after testing, the IC appeared to have no reverse current protection, so it got fried and shorted out. It's no problem whatsoever, since we don't need the IC anyways, unless you need to use the remote functionality. In that case, you need to connect diodes between the IC and the connections we made. As simple as that. It's an easy fix. We remove the whole IC and of course ruin our beautiful wires in the process. Let's reflow everything and call it a job well done. I'll disconnect the IR receiver too, since it's of no use now. I also added this neat connector at the end of the cable. Now let's check if we did everything correctly. Perfecto. Now let's gather the rest of our components. Our brain will be an Arduino. FTDI. Finally, some male-female jumpers to connect everything together. And using some magic, connect the contraption to the LEDs and voila! I have also got this RGB ring light which has addressable LEDs, so let's get a data line in. Welcome to the nerdy part, coding. We could approach this project in many ways, like hacking into this small indie company mainframe and retrieving the game data. But let's be realistic here. Another idea is to intercept the packets between the client and the server, but good luck decrypting and parsing those. We could also tap into the game's memory, also good luck on reverse engineering that. And it's GG when your hard stuck level 69 wood division account gets banned for malicious activity. Maybe just simply use rights provided API services to retrieve the game data, right? You think life will let you off that simply, huh?
Nope.
The API doesn't provide any live game data. So, what to do, you may ask? Use the computer eyes, is what we do, aka OpenCV. We take the part of the screen that we are interested in that case the notification panel and health bar. For the notification part, we'll be looking for the objectives on which to earn them, using pattern matching algorithms to match these images I took of every object and try searching for them in the captured image. If a match is found, we look a pixel to the left of the matched area, and we check the RGB color value of the pixel. Then, with some parsing, figure out the respective teams. In this part, we also take a captured portion of the screen, sprinkle some enhancing magic dust, we use what's called OCR, optical character recognition, and voila, appears your house. As for the Arduino, we set a communication protocol, parse it, then run the predefined modes we coded. For example, fade fast, static, or glow, with the RGB values sent from the Python script. We could also send our custom commands through a serial terminal, so we can run a test. Here is a quick scroll through the code that you can find down below, and let's run this thing.
Into